Alright, so in this activity you were asked to actually go through and divide each of these numbers using the primes that we just found from our sieve. So if I go up here and keep following just my primes, I do 239 divided by 5, which will give me 47.8, divided by 7 would give me 34.14, dot dot dot. And if I keep going, divide by 11, it's going to give me 18 and 3800, dot dot dot. And then if I divide by 13, it will give me 14.05, dot dot dot. And I can stop there and say that 239 is definitely prime. And the reason I can stop there is I can now look and say, well, the next number would be 17. And at 17, I'm going to be flipping my order, just like when we were talking about trying to find the factors of a number. Here I'm using my primes as that factor piece, and at 17 I'm going to end up having something that would have to be smaller than 13. So I've already checked all my options to that point, so that now I know that 239 is definitely prime. So then I'd go through and check 323 and 4001. Now with 323, if I keep going, I do 2, 3, 5, 7, 11, 13. When I get to the point of 323 divided by 17, I end up getting 19. So 323 is a composite number because it has other factors other than 1 in itself. So prime numbers are those numbers that are only 1 in itself. Everything else is composite. Now I'd want to check 4001. Now 4001, I would end up checking a lot of numbers. I'd end up checking all of my prime numbers, 2, 3, 5, 7, 11, 13, all the way up till I got to 4001 divided by 61, and that's going to give me 65.59, dot 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 dot. And when I get to that point, it's not a whole number, so I know that it's not divisible by 61. Well, my next prime is 67. So there again, I flipped beyond my quotient and my divisors there, so I know that 4001 is prime. So I don't have to check anymore. So the whole point of the method is that if I check my primes, when my quotient and my divisor flip to where my quotient becomes smaller, then I know that I'm done. So my divisor is bigger and my quotient is smaller. Now it asks, why don't I check then my composite numbers? Well, if you think about what composite numbers are multiples of prime numbers. So if I think about 6, if it's going to be divisible by 6, it had to be divisible by 2, because 6 is divisible by 2. If it was divisible by 9, it would have to be divisible by 3, and I've already checked 3. 3 didn't work, or did work. So every single composite number is made up here of prime numbers. And that's how we get our factor trees and our products of primes, which we'll talk about a little bit later.